Okay, so the first step in setting up one of these new legacy planes with the flaps occurs during when you're building the airplane. After you've built the airframe and done all the hinging and you're starting to install the servos, the first thing that you need to do is make sure that your servo geometry is set up correctly. The initial servo setup can be done before you've ever plugged them into the receiver or centered them. The main point here is to make sure that you've got the length of the push rod correct. The idea here is you want to have the servo arm parallel to the hinge gap. This does two things for us. It allows us to get full deflection in each direction, but also make sure that the push rod is straight at full deflection, giving you the most amount of torque at the point where you need the most amount of torque. So what I've done here is set up and centered all of the servos in the same way with the correct geometry on the wings and on the tail before I've ever plugged anything into the radio. So now that I have the geometry set up correctly on the servo linkage, I've disconnected the servo arms from the servo before I plug them into the receiver and fire it up for the first time. This will make sure you don't overdrive any of the control surfaces and break any balsa or control links before you have your endpoint set up and your servos centered. Extreme Flight now sells these harnesses that allows you to hook up a 4-servo wing through one connection. This is a great way to set this up so you never have to remember which servo goes to which extension. It makes life a lot easier. I label mine right and left so that I never forget. You can also hard mount them to the airframe on one side or the other. When setting up these legacy aircraft with the flap wings, one thing should be considered is your BEC, or how you're going to power your servos. You've got 4 servos in the wing, 2 servos in the tail, plus the engine speed control. Normally we run those off the BEC that's built into the speed control. But if you're going to be running some higher draw servos or high voltage servos, you might consider running a separate battery to power those servos. In this case, I'm running the Sabox 1260 high voltage servos, and I'm running a separate 1000 milliamp 7.4 volt 2-cell LiPo to power the servos. The extra voltage gives me the full benefit of the high voltage servos without taxing the speed control BEC. If you're going to do that, you need to cut the red wire on the BEC coming off of the speed control. So the plug that goes into the receiver, all you got to do is clip or unplug the red wire. Typically I just unplug it, fold it back, and put some heat shrink on it in case I ever want to plug it back in again. In this case here, I had to run an extension to get back to the receiver, and it was just simpler for me to cut the red wire on the extension on the speed control. Again, this is only important if you're going to be running a separate battery or a separate BEC to your receiver. In this case, I'm using this JST connector, which is right here. This JST connector was simply just soldered onto a servo connector, and that plugs right into the receiver, and that powers my receiver. I've already got the bind plug in there, so I'm going to connect the 2-cell battery and we'll start the bind process. Before we begin setting up the airplane, the first thing we need to do is put some basic parameters in the setup menu of the Spektrum radio. Today we're going to use a DX18. To do that, we need to hold down the scroller wheel and turn on the radio. So I'm going to do it one-handed here. Hold down this button, turn it on. Don't let go of the button until the light comes on, and that gets you into the system setup. Once into the system setup menu, we need to select the model that we're going to use. In this case, we're already on the model, which is going to be called the Bushy, or the Bushmaster. And we're going to select the model type. Obviously, you want an airplane. You're going to select the model name if you want to change it. And then aircraft type is important. In this case, you want to have a 4-servo wing selected with separate flaps. There are a lot of choices in this menu. You can have 2 ailerons, 1 flap, 1 aileron, 2 flaps, 1 aileron, 1 flap, flapperon, which is what a lot of people set up for a normal 3D plane. But with this particular airplane, you're going to want to have it set up as a 4-servo wing with 2 ailerons and 2 flaps. The tail will remain normal. The other thing that I like to do here is to go through the channel assign setup and make sure that we have all of the correct channel outputted to what we want. So throttle, aileron, elevator, rudder is pretty standard. I like to set up channel 5 as the left flap, channel 6 is the left aileron, channel 7 is the right flap. You're not going to need anything else past that for this setup. After channel assign, there is one more menu in this system setup that can be useful for a 3D plane. I'm not particularly using it on this Bushmaster or any of the legacy planes, but I do use it quite a bit on other planes with large control surfaces. The trim setup is used to be called trim step, and what it allows you to do is control how much the trim moves for each click of the trim knob. So in this case, with most 3D planes, you usually have a very large elevator and rudder where one click of trim might create more of a change than you want. So in this case, you can dial your trim steps down, and typically for most 3D planes, I run my trim steps down closer to 3 or 4. But that's up to you if you want to try it. If you feel that this aircraft doesn't trim exactly how you want it to trim, and one click of trim provides too much of a correction, you can come back to this menu and adjust that later if you want. Now that we have some basic parameters set up, I usually like to back out of this and go to the regular setup menu, which is clicking the scroller one time, and to bring it into the servo setup menu. This is where you're going to do most of the changes to the setup. I want to make sure my travels are all set to 100 to start with, so each of these are set to 100. And if you start with a new model, it will be, but if you're starting with an old model where you're just changing the names, you want to go through and check that. The other thing you want to do is make sure your sub trims are all zeroed out. In this case, they're not, so I'll go ahead and zero those out now. So clear each one of those. All right, so now my sub trims are clear. You want to just kind of roll through all these other ones. We'll get to the reverses later. Speed, you want to make sure everything's on normal speed for now. Absolute travel should be 2048 on each channel. If you've never messed with that stuff before, it's not going to be an issue. The dual rate, expo, differential, flap system, all that stuff we're going to set up later. But for now, you want to go into the flap system and make sure that if it's assigned to a switch, you know where the switch is. So you want to start with your flaps in the 0 position. So where it says 0% right there. That's important because when we go to set up the centers on the servos, you want to make sure that that is centered. Now in a lot of cases this will be inhibited, but on this particular model I've got it set up already. So if you do have your flap system enabled, you want to make sure that your switch has got your flaps centered. Otherwise you could end up having to do work twice when it comes to centering the servos. Alright, so once you've got that set up, we can back it out and turn off the radio. Next, I'm going to begin the binding process. I've got the 2-cell battery put in the airplane. I'm going to connect it up, and we're going to get the blinking light on the receiver. Okay, so I've got the receiver plugged in. We've got the blinking light on the receiver and the satellite. We're going to come back to the radio, hold down the bind plug, and turn it on. So now we're bound. Wait for it to say bound. And we're good to go. So we got servo movement and everything that we need to go. So the next step of this is going to be to look at your control horns and see where they need to be centered. Okay, so we got everything turned on now. The sub trims are set up in the radio like we talked about, and we still don't have the ailerons or the flaps connected. But now that the servos are powered, we can figure out where they need to be put onto the servo to find their center. In this case, there's the center. So it's not going to be exact until we sub trim it, and in fact if you look at this from the top side, you can see that we're still a little bit off on the aileron. But that's as close as we can get on the splines of the servo. So we're going to go ahead and install the servo screws now and take care of that little bit of difference there at the tip with the sub trim when we get to it. So now we've gone through the whole airplane and connected the control horns to the servos, but we haven't sub trimmed anything yet. We've gone ahead and installed the servo screws to retain the control arms, and now everything from here forward is going to be radio setup. So you can see that the rudder is a little bit off-centered, the elevator is a tiny bit off-centered, and then each of the flaps and ailerons is just a little bit off from center. We're going to fix that with sub trim. After you have bound the transmitter to the receiver and you've connected your servo control arms and tightened your servos down, it's time to make sure your control surfaces are moving in the right direction. That's where we're going to use the sub trim menu which is part of that same servo setup menu that we started with. So you go servo setup, travel, select the travel, go through subtrim to reverse. And what we're going to do here is just make sure that when you move back on the stick, that the elevator moves up. And when you move forward on the stick, the elevator moves down. And when you move right, you've got right ailerons. And when you move left, you've got left ailerons. And same with the rudder. Right rudder versus left rudder. So to enter the subtrim menu, you just press the scroller, scroll down to servo, scroll down to travel, scroll down to subtrim. And then we're going to go through each control surface one by one and straighten them out. Okay, we'll begin with the right aileron. So I've got right aileron selected, and you can see as I move it, it changes the numbers on the screen. But I really don't care what the numbers are on the screen. I only care what the numbers are on the aileron itself. So I'm going to run the dial until the aileron is centered. And we'll come back to the radio and go to the right flap, just right here, and then we'll do the same thing here. So we've got the aileron and the flap centered all the way across the whole wing. I might make a little bit of adjustment to that aileron. So now it's centered all the way from tip to the center. Now we'll do the same thing with the rudder. If you look at the rudder here, we need to move it a little bit to the left to get it centered. A little bit more, and we're there. Same with the elevator. You see that from the tip of the stab to the tip of the aileron, there's a little bit off there. So we'll move that to get her centered up. And there she's centered. And we'll do the same thing to the other side of the wing. Okay, next we're going to start setting up the travel throws. So we've switched from the subtrim menu to the travel menu. We're going to start at the back of the plane with the elevator. You can see that I have the elevator highlighted with the cursor. And you'll also see that when I move the stick up, it selects one travel. And when I move the stick down, it selects the other. We're going to hold the elevator in the up position and work the elevator throw to get maximum throw. So what I'm looking for here is maximum mechanical binding of the elevator. I want to get as much throw as I can get until the elevator maxes out. Now if you watch the servo arm here, you can see it stops moving. Moving now with the sub trim or the throw trim, and then it stops right about there. So I want it to be right before it stops to stop any sort of binding of the servo. And if we come back to here and look at what that number is, that's 128. Now we'll do the same thing on the down side. We'll run down elevator forward until we get binding. It's about right there. We'll back it off a little bit. And that gets me maximum throw on the downside. And we've looked here and we've got 128 on the down, or excuse me, on the up, and 146 on the down. Now we're going to move on and do the rudder. Next we're going to work on the rudder, and it's the same kind of thing. We're going to run it to the end point that gives us the maximum throw without any kind of mechanical binding. I will hold the stick in one hand and run the scroller with my thumb. And you want to make sure that it goes all the way to its point. So right now I've exceeded the way the rudder will go. I'm going to back it off until it starts to move again. Right about there. Same thing in this direction. That's your maximum point. Back it off until it moves again. And then one other thing to think about with this airplane is your elevator throw. So if we have elevator throw and maximum rudder, there is a point there where they could intersect. So you want to make sure that you don't have more elevator throw than will intersect with the rudder. And you can see right here that it just happens that on my airplane the max mechanical point is just about perfect for clearance on the rudder to elevator. Next thing we're going to do is the right aileron. And much in the same way, I'm going to run the control surface all the way to its endpoint and run the travel to where we get maximum mechanical throw. Just about right there. We'll run in the same direction down we'll get max mechanical throw. Now in this particular case, you can see that you get much more down throw than you get up throw. And there's two ways to solve that problem. The first way is with a pitch gauge. You can make sure that you have equal amounts of throw in the up direction and the down direction. Another way to do that would be to come back to your radio, and you can see here where we have 139 in up throw and 139 in down throw. So if I back this down to 139, I'm going to get equal amounts of throw, theoretically, with the aileron. Now that's a quick way of doing it, and with some airplanes I would prefer a pitch gauge, but with a high wing airplane where the roll may not necessarily be as axial to start with, this will give you a jumping off point that you can mix out later. So using the measurement method, I ended up with a end trim of 110 on the downside and 139 on the upside to get 53 millimeters of throw equal across all of the ailerons. One trick you can use if you're setting this up by yourself is to use a little bit of blender and tape to hold the stick for you. But you can see here that that 110 endpoint gives us the same 53 millimeters on the throw. And the third way of doing it is to use a pitch gauge like we have here, and you can measure the amount of throw that you have in the up position, which is the shortest amount of throw. We get about 37 degrees. And you can set your endpoints on the bottom to get the same 37 degrees here, which is what we've got. And in doing it that way, we ended up with an endpoint of around 115, so it's about 5 different than the measurement method. None of those methods are perfectly accurate, but as long as you get it close, you'll be able to trim out what happens after that in the air. But there you go, that's how you set your aileron throws. Okay, once you get the ailerons done, we're going to do the same thing with the flap. Now we've got that 3-position switch set up right in the center, which is the one that's manually connected to the flap switch in the radio. You can make it whatever switch you wanted, but I like to use that switch because it's right above the throttle channel. So we're going to set the flaps to the down position, and we're going to run the endpoints out again, same way that we did with everything else. You want to get the maximum mechanical throw before you get binding, and you can hear the servo. Right before the servo binds, and that's about 111 of down flap. We'll go to the upside and do the same thing. So we get a bind, and in this case we can go all the way to the stops. So I've got a really long control arm on this, which gives us a huge amount of control throw. And now we'll do the same thing with the other flap. We're going to run them all the way to the mechanical stop. And then you want to look at your radios for your flap positions and see if they're very close. So in this particular case, if you look at my flaps, the right flap is 147 and 150, and the left flap is 111 and 150. So I want to make sure that the flaps are moving in the same amount up and down visually, and you can use the pitch gauge for this too, but I think visually actually gives you a better idea of how close they are. So now we're looking down the wing at the two flaps in the up position. You can see that the left flap, the closer flap, is getting a little bit more throw than the right flap. We will adjust that with that endpoint to bring it back into line. Okay, so now we will bring this flap back down where we get a match. So if we look down the flaps, you can see pretty closely that those are moving exactly the same amount in the up direction. Flaps in the down direction are a little bit more difficult to look at, but if you stand the airplane on its nose and look from below, you can see that the right flap is extending a little bit more than the left flap. We'll fix that with endpoint. So now we're looking at adjusting the right flap. So we'll come over here to where it says right flap. We've already got the switch in the right position. We're going to look up here into the flaps and back them down until it matches the amount of throw that we're getting on the other flap. That is pretty close right there. So at this point, we've got everything set up with maximum amount of throws. We've got up elevator, down elevator, left rudder, right rudder, and they are not touching, which is important. We've got right aileron, left aileron. We've got flap centered, flaps down, flap centered, and flaps up. This is a basic setup that you could fly with no further changes. However, I'm going to show you a couple things and tweaks that we like to add to the airplane to make it more flyable and more interesting. First thing we're going to look at is dual rate and expo. Personally, I do not run dual rates on most 3D planes, I just run expo. But what we want to do on Spektrum radios is positive expo reduces the sensitivity in the center of the stick. Typically for me, I like to start with ailerons around 25, elevator around 75, and rudder around 65. Now if you talk to some of the young super pilots of RC, they'll tell you those numbers are higher than they like. Most of those guys start with 50 and work down, but those are the numbers that work for me on this particular airplane, and a lot of people have found that it was a very comfortable thing. If you wanted to have a dual rate, all you'd have to do is go here where it says dual rate and change your throw down to a different number. So in this case you could make it 75. So after you've set up your dual rate, you're going to want to put it on a switch that you can find. You can put it on the flight mode, or switch A, B, C, D, or whatever. I think the natural aileron dual rate switch is switch F. So once you've selected a switch, you can see those are your full rates, and those are your low rates. Again, that's something that's going to be personal preference. For me, I don't want any of that, so we will turn that off and go dual rate 100%. So after we've set up the dual rate and exponential that you want to have, we're going to back out of this menu and scroll down to the flap system. The flap system gives you control of what your flap switch does, but also more importantly, what your elevator trim does. So with the way that we have these set up typically for the 3D planes that have flaps, there's a center position here on the switch, which means the flaps are zeroed out. Down gives you normal down flaps, center gets you back to zero, and then up switch gets you what we would call spoilerons, which are basically the flaps in the up position. So one of the things that happens though is when you move the flaps, the chord of the wing changes and you need a corresponding elevator trim change. So if you look at this flap system here on the right column, elevator trim is already built in. Now I've set up enough of these models to know that when I put the flaps down, I need about 6% in down trim for the way that I like to set up the airplane. Now if you have less less elevator throw or a different amount of elevator throw than I do, that number will be different. But I found 6 is a good place to start. So if you look at when I move the flaps, you get a little bit of a down switch there, just a teeny bit. So when you have the flaps in the down position, it actually changes the way that the airfoil reacts to the wind. And in this case, lowering the flap actually increases the angle of the attack of the wing. So if I run a straight line from the leading edge of the wing through the bottom of the flap, that's the direction that that part of the wing is going to want to fly now that the flaps are down. So that makes the airplane want to fly in a nose down condition. But if you follow that attitude all the way back up to the tail, you can see now that you have the tail pointed straight up in the air, and it's in effect giving up elevator to the wing. So you need to trim that out with that down elevator in the flap system. This pitch up with down flaps and pitch down with up flaps tendency is even increased after we mix the ailerons into the flaps, which we're going to do next. So with all of that discussion about how you need down trim when you put the flaps down, strangely enough I found with this airplane, when you put the flaps in the spoileron position, which is the up position, that you don't need any trim at all. to make that work. Not sure exactly why that is with this particular airplane, but from one airplane to the next you can have a little bit of variation, and in this particular airplane I found that you don't need it in the spoiler-on configuration. Okay, the next thing we're going to do is come out of the flap system and go into the mixing system and give you some added functionality in your airplane. In this radio there's a couple of pre-made mixes that we're not going to use, and we're going to go straight to mix 1. This mix is going to give you flap to aileron, and we'll have it turned on to switch E. And basically what this allows you to do is have full span flaps across the whole wing. So we're going to go flap as the master, because when we move the flap switch, which is a switch here, we want it to move the aileron to the down position. So we're going to go flap, switch to left aileron. We'll leave the rate where it's at for right now. Offset we're not going to mess with. Trim we're not going to mess with. And we're going to set it up to be on switch E, and we're going to have it on in the middle position and on in the second position. So this is switch E. Right now it's in the first position. I'm going to move it to the middle position, which will allow us to turn it on. So if you watch here, it's off, and then there's a little ticker at the bottom of the 0, 1, and 2. You'll see that move to 1. So now that we've turned that on to where we have it enabled in the 1 and 2 position and off in the 0 position, we'll come back up to the airplane and look. When I put the flaps down now, nothing happens. But if I switch the E to either of the other 2 positions, we now get the flap to go down with it. Or the aileron, excuse me. So now we have flaps coming down with the ailerons. And if we move the flap switch back to 0, they all go back to 0. If we move them up, they all go up. So now that we've had that on that switch E, if I move that switch E back to the center, that turns that mix off. So that gives you flaps by themselves, and then when you turn switch E on, you've got flaps and ailerons together. Now let's talk a little bit about the throw. So right now you can see that I do not have as much flap throw as aileron throw. And one of the reasons why is that when you set up this type of flaps where you got flaps across the entire length of the wing, if you have too much flap at the tip, it can give you an airplane that likes to tip stall. The other reason is you want to maintain some kind of aileron control. And if you use up all of your ailerons in the down flap position, you're not going to have much aileron control left. So in this case, I don't like to use all but of about 70 or 75% of the ailerons in the flap position, just so I can maintain some aileron control and not have an airplane that likes to tip stall. So we just added the flap to aileron mix, and we put it on switch E, which allows us to turn it off or on. And now we're going to add another mix called aileron to flap, which does the opposite. Instead of mixing the flap and ailerons together, we're going to mix the ailerons to the flaps. So when we move the aileron stick, the flaps will move and act like ailerons. So we'll click on this mix. We're going to select the aileron as the master, the flap as the slave, and in this case we use the left flap because the left flap is the master. So if we mix it to the left, it'll actually make them both move. We'll come back to the endpoint here. We don't need an offset. We don't need trim. We just need to turn it on just like we did with the previous one for the 2 switch positions on switch E. Now if we go to switch E, it's a 3-position switch. 1, 2, 3. I like to have it to where it's off, and then when I turn it on, I don't have to think about whether I stopped in the first position or the second position. I can just slap it down and it's on, slap it up and it's off. That's why I have here selected on in the 2 and 3, or the 1 and 2 position, and off in the 0 position. That's just a personal preference. Now, if we turn the switch to the off position, come back to our wing, we've got normal ailerons and normal flaps. Now I'm going to turn switch E on, and now we have ailerons and flaps working together full span. So this is my preferred way to fly it. And in fact, in my setup, I don't even have switch E as an option. Everything's on all the time. So I get full span ailerons all the time, and I get full span flaps all the time. And when the flaps are down, you get full span ailerons too. So this gives you an airplane that'll fly extremely slowly, and you still have lots of control authority with the ailerons this way. And at high speeds doing 3D stuff, it gives you the most aileron control as well. So this is my preferred setup, but you can leave it on a switch if you want to be able to turn all that stuff off and just go back to normal beaver control. So it's worth pointing out at this time that when we have the aileron set up this way, I've got the inboard flap part of the aileron moving more than the outboard part of the aileron. One of the reasons that we do this is because when the airplane is rolling, the wingtip area, or the outer portion of the wing, has more leverage than the inner portion of the wing. So if you want an equal pressure across the wing, you need to create more force in the center than you do at the tip. If you look at a lot of airplane designs, you'll see that they have tapered ailerons to accomplish the same sort of thing. It's optional though, and you can play around with it and see what you think. I personally think it looks pretty cool. So one final mix is crow or butterfly. I've showed you how to move the flaps and ailerons together and how to make the ailerons move the flaps, but now I'm going to show you how to make them split and go in different directions. So first mix, flap to aileron gave you full span flaps across the wing. Aileron to flap gave you ailerons full span across the wing. Now I'm going to add two more mixes. It's going to be the switch E, which is the one we set up before, to the right flap, and switch E to the left aileron. So we're going to go to a mix. We're going to create it as switch E, which is the same 3-position switch we've been using. We're going to make that the master, and now we're going to make the right flap the master, and we're going to come down to rate. And we're going to switch this all the way to 3. And we're going to come over here to rate and run it up. So you can see here what we've done is by selecting the switch to the flaps and you move the endpoints, we've now got control of the flaps. So 104 was the number that I found where they were equal across both of them. And then you'll also see here that we've got no trim, we've got switch E selected, and now we only have it on in the 3rd position. So the previous two we had them on in the middle and the 2nd position. Now this switch, or this mix, we've only got turned on in the number 2 position. Now we're going to go back to the last one, which is going to be switch E to the left aileron. This is going to make the ailerons go up. So we've got switch E as the master, left aileron as the primary. We've got the endpoint set to 100, no trim, no offset, switch E on in the last position. So what this does, we go here, so this is switch E in 0 position, so we've got no mixing of ailerons and flaps. We can put the flaps down and they're not connected together. If we go to switch E in the middle position, now we've got full span flaps, or full span ailerons, excuse me, and full span flaps in the down and the up position. But now when we move switch E to the 3rd position, we've got crow. So that gives you ailerons up, flaps down. Ailerons up and flaps down. Now the one key point or reason that you would use crow is it provides the same amount of drag as having all the flaps down, but it doesn't create as much of a pitch change. So you don't need to trim the elevator out as much for that. So if you're doing like a high speed dive and you want to slow down, this is the best way to use that because you don't have a big pitch change associated with it. And also because you've got spoilerons at the tips and flaps in the center, this scenario is less likely to tip stall than others. But now that we've got everything mixed together in the third channel, so not only do we have crow, but we got ailerons, and when we want to have more flaps, we can get more flaps. And when we want to have less flaps or spoilerons, we can get pure spoilerons. So this gives you a condition that is very mixed, and it can get confusing if you don't remember how your switches are. So that's why I typically don't use crow. I typically have my airplane set up just like this all the time. So you got full span ailerons, full span flaps. Nothing ever turns on or turns off, and all you've got to worry about is putting the flaps either up or down as required. Alright, so the last mix that we're going to talk about today is elevator to flap mixing. There is some pre-mixes built into the radio that'll do that, but I like to start over with a clean mix. So we're going to go to mix 5, which is right now something that's not turned on. In this case, we're just going to do a normal. You could do a curve, but a normal for this works fine. We're going to pick the master as the elevator, and the slave is the right flap. Excuse me. And now we're going to mix the elevator to that flaps. So right now you can see nothing's happening with the flaps. And what will happen is as I dial in the endpoints, you can see the flap starts to move. What you want to have is up elevator to down flap. So up elevator, down flap. And in this case, we'll probably just go about 50% on the radio throws. And for down elevator, we'll do the same thing. So in this case, we want, when down elevator is applied, we want the flaps to go up. Up elevator, flaps go down. Down elevator, flaps go up. And we're going to set the rate to about 50%. Now you can also put this on a switch if you wanted to. We're running out of switch positions on switch E, so we could put this one on to switch F. And we could say F is also a 3-position switch. So we could say off, on, and on. So with switch F in the first position, we've got no mixes at all. And then with switch F in the middle or bottom position, we've got flap to aileron mix. So the other thing you could do there, if you wanted to, would be to mix the elevator to the ailerons to get you the same sort of input across the entire span of the wing. So again, we would go switch normal, or mix normal. We're going to have the elevator be the primary, and we're going to try right aileron and see which one of those works. So with right aileron, you can see that the left aileron moves up like it's supposed to, but the right aileron is moving opposite of the flap. In that case, I found with the DX18 anyway, that if you switch to the other aileron, you go from the right aileron to the left aileron, you're going to find that it does what you want it to do. So now you're going to see the aileron moves up, the aileron moves up, and so now we're just going to do the same thing here and switch it to 50% throw. So now we've got flaps up, ailerons up, flaps down, ailerons down. There you go, mix is set up. Okay, so now we've got the airplane set up, and I'm going to talk a little bit about how to trim it out in flight and to make sure all this stuff works the way you want it to. So in your initial maiden flight, you're probably going to want to take off with the flaps in the neutral position versus the up or down position, and just get everything trimmed out, get your expos set up the way you want them, get your throws set up to where the airplane flies exactly like any other plane that you would want to fly, and you've got everything working properly. Then on the second flight or later in the first flight after you've got all that set up, we can start messing with the flaps and figuring out how to do the mixing. There's a couple points on flaps that I want to bring up. First is they create a lot of drag, and you're taking a big control surface and you're sticking it out into the wind. In some cases you're taking a lot of control surfaces and sticking them out into the wind. And if you do that while you're going really fast, you can actually hurt the airplane. I mean, if you were doing a high-speed dive in one of these planes and dropped all the control surfaces out on the wing, you might break some hinges. We haven't had that to date, but it is something that's possible and over time can have a cumulative effect on the airplane. But one of the things that you want to do when you're setting up the trim for the flaps is to get the airplane flying in a good, smooth, straight and level, wings level flight, kind of like it's looking on the bench right now, at a reasonable speed. I would say maybe quarter to half throttle. And then drop the flaps in. Just the flaps, not the crow, not the aileron flaps, nothing else. So you got your switchy in the first position, so it's just like a normal airplane with flaps down. And see what the airplane does. If the airplane continues in a straight direction and doesn't balloon up or push down, that's the exact condition that you want. If it decides to balloon up, immediately turn the switch back to the neutral position, come around and land, and add a little bit more down elevator mix into the flap system. Then go back up into the air, get it trimmed out straight and level, about a quarter to a half throttle, drop the flaps down again. It should continue exactly straight and level. If it doesn't, come back and make another elevator adjustment. After you've got that elevator trim mixed in the way that you want it, and again for me on this airplane, the way it's set up right here, 6% down trim to the down flaps does the trick for me. Then the next thing you want to do is get it into what I would call a landing configuration speed. So now instead of a quarter to a half a throttle, you're at idle, making a steady 3 to 5% glide slope to a runway. And then put your flaps down and see if it continues down that same glide path or if it balloons up or down, and maybe make another little trim change to make sure that it's good on the landing descent for the way that the flaps are trimmed out. Since flaps are primarily used in that landing configuration, that would be the most important part to me, would be to make sure it's trimmed up good for landing, because you're not going to use them a lot at high speeds. Then, after you've got the flaps set up and trimmed out the way that you want it, you can do the same thing. Get it up in the air, get it leveled out right side up, put the flaps down, make sure it's tracking in the same direction, and then you can turn your switch E on, which also puts the ailerons in the down position, and make sure it doesn't need any additional switch change, trim change from there. So once you've got the kind of balloon and the flaps out in the downside, you can do the same thing in the up position. For me personally, the spoiler on position, like you see right here, its main goal in life is for a parachute type descent or a falling leaf type of descent. If you stall the airplane with full up elevator and put the spoiler-ons in that full up position like you see here, it'll fall down perfectly straight, and with any kind of headwind it'll even fall backwards. Some people like to use this for Harrier. It kind of gives you a modified Harrier where the wing isn't actually stalled. Maybe that's a good tool for learning how to Harrier, but this airplane doesn't have any wing rock or any sort of bad 3D tendencies. So you don't really need it for that, but you could use it for that. So once you've got all of that set up and the flaps down work and the spoiler-ons work like you want, you can do the same thing with the crow. So you can put it on, typically for me I use the crow on a straight down line, so I'll have power off, I'm driving it straight down towards the ground, and I can kick the crow out and see if that creates any sort of pitch tendencies. Now because the crow isn't really using the flap system, and I realize there are other ways to set up crow within this radio, but because crow is not using the flap system, it doesn't have a native elevator trim mixed into it. So if you have a balloon or a pitch change when you go to crow, there's two ways to correct it. One way would be to correct it by changing the amount that the flaps go up and down to kind of take some of the balloon out. Or you could mix a separate mix That will give you the switchy in the third position, which is the switch that turns that on. You can mix that switchy, the elevator, and do an offset for a little bit of down trim that way. So you'd have to use an extra mix, but it could be done that way. Okay, so lastly, the last mix that we had put in was the flapped elevator mix. So you can see here, elevator up, flaps down, elevator down, flaps up. Again, you can see here that I have the center flaps moving more than the outboard flaps. You can play around with that and see what you like. This gives you a very tight tracking loop inside and outside. Gives you kind of 90-degree turns at speed. For me, it doesn't do too much in the 3D realm. It's more of a high speed. I think at this plane anyways, flops better without the flapped elevator mix. But some people might like the flapped elevator mix for doing real tight waterfalls or end over end kind of loops or something like that. So you just have to play with it and see what you like. But you'll notice that with all of these mixes in place, you've got flaps, you've got full span flaps, you've got crow, and even during crow, you can have various mixes of flaps up or flaps down, and then you can even add to that your elevator to flaperon mix. All of that can get complicated, especially when you're flying and thinking about something else. So one of the things that I recommend is that when you set the airplane up, set it up with all of these mixes, and then for a while, each flight you go up, try one of the new mixes. Try your full span ailerons and see if you like it. And if you like the full span ailerons, then you keep that mix in. If you don't like the full span ailerons and they don't do what you want to do, turn that mix off, because it's just an added switch on your radio that's going to give you an unknown flight condition in the future when you accidentally hit it. Then maybe on the next flight, you can try your crow and see if you like the way the crow works, and mess around with it, trim it up to get it to work the way you want it to, or you may decide that you don't like it, and if you don't like it, turn off the mix. The same with the flaps. If you like the full span flaps, leave them in. If not, take that mix off. So ultimately, you get it all boiled down to how you want the plane to fly. And the way that I have mine set up to fly the most is where you've got full span ailerons all the time, full span flaps all the time. I don't use crow at all, so I've got crow turned off. And the elevator to flap mix, I don't use it all either, so I have that turned off. But you talk to my friend Cody, and he flies with that flap to mix all the time. So it just depends on who you are and what you like to fly. But the cool thing about these airplanes and all the control surfaces is you can really customize it to the way that you want to fly.